Hey guys, what's up? First of all, thank you so much for tuning in to my channel, Architect Square. Today's episode is all about cement. Is it concrete? Probably no. Or is it mortar? Really? Definitely no, it's not. If you answered as I did, then probably you should hang on. Where did the term cement derive from? Wikipedia says it's from Latin word cementum, which meant the stone chippings which were used in Roman mortar. Cement in general is the adhesive substances of all kinds, but in a narrower sense, the binding materials used in building and civil engineering constructions. In fact, the origin of hydraulic cements goes back to ancient Greece and Rome. The materials that are used in these buildings were lime and the volcanic ash that slowly reacted with it in the presence of water to form a hard mass. The definition according to Oxford Dictionary. Let's see what goes in the manufacturing of cement. Quarried and crushed iron oxide, shale, silica, and limestone are mixed together and run through a rotary kiln. This forms clinker, which is ground to fine powder and mixed with gypsum and then bagged for sale. If we bottom down to the types available in market, they are generally three. These are ordinary Portland cement, Portland polyzonous cement, and Portland slag cement. All these three are known as OPC, PPC, and PSC in short. Usually we buy ordinary Portland cement, that is OPC, based on their grades, that is OPC 33, OPC 43, and OPC 53. OPC 33 mostly has been phased out in the country. This grade of cement is used for general constructions under normal environmental conditions, but low compressive strength and availability of higher grades of cement have impacted the use and demand of OPC 33. OPC 43 is nowadays largely used in plastering, flooring, and other non-structural applications where OPC 33 was earlier being used. It's used for general RCC constructions where the grade of concrete is up to M30. And the last one in the line is OPC 53, which is used when we need a higher strength concrete at a very economical cement content. This cement grade is used for specialized work such as pre-stressed concrete components, precast items such as paving blocks, building blocks, etc. There are also several other types of OPCs which are being used in construction. Starting with sulfate resisting cement, which is also known as SRC. This is used where the concrete is exposed to the risk of deterioration due to sulfate attack. For example, in contact with soil and groundwaters containing excessive amount of sulfates, as well as for concrete in seawater or exposed directly to the sea coast. Then are the colored cement, which are made by grinding 5 to 10% of suitable pigments with white or ordinary grey Portland cements. Air entraining cements. These increase the resistance of the concrete to freeze and thaw damage in cold climates. These are made by addition of about 0.05% of an organic agent that causes the entrainment of very fine air bubbles in a concrete. Low alkali cements. These are used in concrete made with certain types of aggregates that react with alkalis to cause an expansion that can restrict concrete structure. Then we have the well-known masonry cements. These are used primarily for mortar. They consist of a mixture of Portland cement and ground limestone or any other filler material with an air entraining agent or a water repellent additive. Waterproof cement is the name given to a Portland cement to which a water repellent agent has been added. Last in the series is the oil well cements. These are used for cementing works in the drilling of oil wells where they are subjected to higher temperature and pressures. PPCs doesn't have much of varieties in the market, so we can move on to Portland slag cement, that is PSC. One of its kind is supersulfated cement. The strength properties of supersulfated cement are similar to those of Portland cement, but it has an increased resistance to many forms of chemical attacks. Now here are the compositions of three types of cement as we discussed. A very big shout out to the people who stayed back and to those who are willing to stay and watch till the end. So let's hurry up with the rest of the contents. I have added few more types of cements simply for the sake of completeness of the topic. What we have here is the high alumina cement, which is a rapid hardening cement made by fusion of a mixture of bauxite and limestone. Number 2 here is expanding and non-shrinking cements. They expand slightly on hydration, thus offsetting the small contraction that occurs when fresh concrete dries for the first time. Now comes the very well-known gypsum plasters. These are used for plastering, the manufacture of plasterboards and slabs, and in forms of floor surfacing materials. These gypsum cements are mainly produced by heating natural gypsum and dehydrating it to give calcium sulfate hemihydrate. This hemihydrate is also known the plaster of Paris. This sets within a few minutes on mixing with water. This is used for building purposes as a retarding agent, and normally keratin, a protein, is added. Mortar is a building material used for protect or decorative coatings of walls and ceilings, and also for molding and casting decorative elements. Little insights on OPC cements. These are the most commonly used cement worldwide. It is hydraulic, means that once curing with water is complete, it becomes water resistant. It's composed of 95 parts of limestone and 5. It has a high compressive strength, and being an all-purpose cement with fast setting time and strength, OPC grade cement, it has a variety of applications in residential and industrial buildings as well as slabs, roofs and bridges, etc. Next is the PPC, Portland Pozzolana cement. The important fact here to be noted is PPC is environment friendly as it consists fly ash in some specific percentages by parts, which is a waste product of burnt coal, usually collected from thermal power plants. Finally, the last one is Portland slag cement, that is PSC. This is commonly found in ready-mix concrete, precast concrete, soil cement, and high temperature resistant building products. Okay, So this video has been really long, so I'm just winding up with 2 more animations which probably you could read it or just slow down the video and go through it in a glance. A big shout out to the people who stayed till the end. And if you guys liked our efforts, please do like, share and subscribe the video, and do ask your friends to do the same. And if you have already banged the bell button, thank you for encouraging us.